Mathematical representation of phasor. A phasor can be represented in two different ways, rectangular form or polar form. Here we can see this is the equation of instantaneous voltage. V of t is equal to Vm sin omega t plus phi. We can represent this instantaneous voltage using phasor as shown in this figure. Here we can see this is the x component of phasor and this is a y component of phasor. This phi represent phase and this r represent amplitude or magnitude. And as we know that the phasor rotates in counterclockwise direction or anti-clockwise direction. A phasor is a complex number that represents the amplitude and phase of a sinusoid. So as we can see here, it is representing amplitude, this r representing amplitude or magnitude, and this phi representing phase of a sinusoid. Now, the phasor can be represented in two different ways, rectangular form or polar form. So here we can see z is equal to x plus jy, where this z is the complex number, this x is the real part of z, and this y is the imaginary part of z. So this is called as rectangular form. The addition and subtraction are better performed in rectangular form. So whenever we have to perform addition or subtraction, that time we convert the phasor into rectangular form. So this is called as rectangular form, where x is real part of z, j is equal to under root minus 1 and y is imaginary part of z. Then next is polar form. So here we can see z is equal to r at an angle of phi, where this z is again complex number, this r is the magnitude of z, and this phi is the phase of z. Now whenever we have to perform multiplication or division, that time we convert the phasor into polar form, because multiplication and division are better performed in polar form, where r is magnitude of z and this phi is phase of z. So this is called as polar form. Also, z is equal to r into e to the power j phi. This z is the complex number and this is the exponential form. Representation of a complex number. Here we can see this is a representation of a complex number where this horizontal axis is a real axis and this vertical axis is a imaginary axis. Z is equal to x plus jy. So this is a rectangular form, r at an angle of phi, and this is the polar form. So here we can see this is r, this is z, and this is y, and this is x. Now suppose we have to convert rectangular form to polar form or polar form to rectangular form. So to convert this rectangular form to polar form, we can use these formulas. R is equal to under root of x square plus y square. So from this we will get the value of this r, and to get the value of this phi is equal to tan inverse of y by x. Also, suppose if you want to convert this polar form into its equivalent rectangular form, so to get the value of this x, we will use this formula, x is equal to r cos phi, and to get the value of this y, we will use this formula, y is equal to sine phi. So from this formulas we can convert rectangular form to polar form or polar form to rectangular form. Z may be written as z is equal to x plus jy is equal to an angle phi is equal to r in bracket cos phi plus j sin phi. So this is how we can write this z. Here, if we replace this x by r cos phi and this y by r sin phi, then from this we will get this equation. So it is, we can get this equation using these values, x is equal to r cos phi and y is equal to r sin phi. Now here a phasor diagram showing V is equal to Vm at an angle phi and I is equal to Im at an angle minus theta. So here we can see this is a complex plane where this horizontal axis represent real axis and this vertical axis is the imaginary axis. Now as we know that the phasor rotates in counterclockwise direction or anti-clockwise direction. So this direction is called as leading direction, and if it is rotating in this direction, that time it is called as lagging direction. So this is a leading direction and this is a lagging direction. Now if we have to represent, suppose V is equal to Vm at an angle phi. So here we can see this is a Vm. This Vm is the magnitude or amplitude or maximum value of voltage, and it is rotating in counterclockwise direction with positive phase angle. So when the phase angle is positive, that time it is leading. It represents leading phasor. So here it is a leading phasor, and when it is negative, here in case of this current, I is equal to Im at an angle minus theta, this is representing lagging phasor, and this will be in this direction. Here we can see this is the amplitude or magnitude or maximum value of current Im, and it is rotating in lagging direction. So this is lagging and its angle is minus theta. Now here we can see this is a time domain representation and this is a phasor domain representation. So here in time domain representation, V of t is equal to Vm cos omega t plus phi, and in phasor domain representation it is V is equal to Vm at an angle phi.